It's another math day here with teacher Jenny. Join me for another discussion on sampling distribution. This time, this is the part 2 of my video on sampling distribution. So kindly check out my first video on the sampling distribution. And please disregard the last one, the last statement that I made there about this sample mean, which is 92. That is actually the population mean, which is 92. So I'm kind of confusing there. Anyways, so let's now get to another example. So this time, I will be showing you how to get the number of combinations that you need to consider so that you will have your guide for knowing whether you've got there all the correct combinations for that data. Let's start with our example. So suppose we are to construct a sampling distribution for the following data. So we have 123, 126, 129, 132, and 135. So suppose this is our population and we wanted to select randomly. Let's say, for example, let's start with our sample size as 4. Now, for the sample size as 4, our n there will be equal to 4. To get the number of combination, then we will be using combination formula. I hope you can still recall this one. N taken R, that will be equal to n factorial over n minus R, quantity factorial, times r factorial. This is your combination formula. Now, anyways, if you've got there a calculator, you may use the calculator, locate your NCR button in there, and then you can just input your sample size and then the number, the population size, and so with the number of sample size. So please do not be confused here. For our formula, we're using n. You might be confused for the sample size here. The n here is, by the way, our data there. So we've got 5. Our r there, we've got how many sample size or what will be our sample size based on our research or study. Then I might have it as 4. So we have now n taken r, or we have 5 taken 4. So this would simply mean that in my data, which consists of 5 values, I will be just getting a combination out from it by 4. So we'll be getting 4 numbers as one combination. So how many of those 4 numbers can we combine? So we can now solve. We have 5 factorial over 5 minus 4 factorial times your 4 factorial. So inputting that one in your calculator, you will get the value which is equal to 5. Now, to show you that it should be 5, you can have it like this. We can actually interpret your factorial as 5 times 4 times 3 times 2 times 1. So that's how we define factorial. So we can rewrite this one as 5 times 4 factorial. Now, why am I writing this one? Because I wanted to cancel out the 4 factorial on my bottom part or denominator part. So interpreting the denominator, we've got 5 minus 4, which is 1 factorial, 4 factorial. Now, we can cancel this out so that to avoid longer computation if you are doing this one manually. But if you've got their calculator, no need for you to go through with the hassle of computing this one. So we have 5 over 1 factorial is simply 1. So we have our combinations, or the number of combinations that we are expecting is 5. So we will be combining those numbers and you will get 5 combinations out from the data. So let's try to find what are those 5 combinations. But before that, let us try to compute for our population mean so that we will be guided along the way as to what will be our possible sample mean for every combination of your sample. So how to get your population mean? We have our mu, that will be equal to the summation of your x values divided by the sample size, which is n. Our x values, we've got 123 adding with 126, and we're adding that one with 129, and we have 132 and 135. We're dividing that off with our 5 in there as a population size, because we've got 5 data. 1, 2, 3, 4, 5. So computing for that one, if you've got a calculator, you can compute along with me. We have 123 plus 126 plus 129 plus 132 plus 135. We divide that one with the population size, which is 5. We have our population mean as 129. Or the average of your population is 129. Now again, if you go back to the topic on parameter and statistic, we have this one as parameter, the 129. This is a descriptive measure in which we take this as the parameter because this is a description for your population. So I hope that's clear. Now moving on the construction of your sampling distribution, we then construct our different combination and find its sample mean. So we have a table for your values for the combination and its sample mean. So out from the data, I can combine 4 values, and that will be taken as my first combination. So we start with 123 because we are arranging that one in an increasing order. So we start from the smallest. Now, there should be no repetition on the combination. So we must be careful on this one. How to do it? We have to start from 123. That's the first number on the combination. Next number is 126. That's the second one. Take note, we have n equal to 4. So that means to say we must have 4 numbers on one combination. Next number to that one is 129. So you just have to follow it. And lastly, we have 132. So that will be our first combination of 4 values on your data. Next combination, we might start again, or we have to start again with 123 because we only use until 132. So that means to say we can still follow through with the first 3 number here, and we change the last one with 135. So we have 123, 126, 129, 129, and we have 132. 5. Let me just erase that one. Okay. So that will be our second combination. Now, since there's no other number after 135, so we stop with our combination on 123, 126, 129 in there. So we go for the next one. We're done using 126 right after 123. So again, we have to start with 123 because we still have another number there to combine with. So next we have 123, and yet we can use our 126. Sorry, in that one a while ago. We can use 126, but this time we are not using the 129. Instead, we can use the 123 because you can come up with a 4 if you've got 123, 126 as the starting, and then you will be combining that with the rest of the 2 numbers on the data. We have 132 and 135. So we have 123, 126, and then we have, instead of 129, we go for 132, and then 135. Now next, we cannot have any other combination for 123, 126. Now we go for the next one. We can have 1, 2, 3. We check if we can have 1, 2, 3, 1, 2, 9, and see if we can come up with 4 numbers on that combination. So 123, 129, 132, and 135. That's one combination. We've got four numbers on it, so that can be considered as one combination. So we have 123, 129, and 132, and 135. And lastly, we cannot come up with a 123 and another combination for that 123 there. So we can go for the 126. So 126, if you try to look at that one, we can come up with four numbers on one combination. So we have 126, 129, 132, and then 135. And upon looking at that one, you cannot come up with a four-digit combination there. So that is our last one. And again, we have solved for the number of possible combinations that we can come up with this set of values as 5. So if you try to look at this, we have 1, 2, 3, 4, 5 combinations. So that means we're done with that one. So next up, after we determine our possible combinations of the sample, we go for finding the sample mean. In finding for the sample mean, we are simply adding the entire combination. We divide that with how many elements of the combination or how many numbers are on the combination. We've got 4 here. So we add 123 plus 126 plus 129 plus 132. We divide that one with 4 because we have 4 numbers on one combination. And this is equal to 127.5. And this is our sample mean for that combination of the sample. So next sample, we go for adding this one and dividing that by 4. So 123 plus 126 plus 129 plus 135. We divide that up with 4 because there are 4 values on one combination. That will be equal to 127.5. Next combination, we have 123, adding that with 126, 132, 135, and dividing that again to your 4 as the number of values in one combination. This is equal to 129. Next up, we're adding 123, 129, 132, 135. We divide that with 4, and that is equal to 129.75. Next, we have 126 plus 129 plus 132 plus 135. We divide that with 4, and this is equal to 130.5. So those are now our combinations and the sample mean. So we are now ready to do our sampling distribution or to construct our sampling distribution in a way of table. So again, in constructing your sampling distribution, we have to know the sample mean and its corresponding probability. So writing down in increasing order, we start with the smallest sample mean there, which is 127.5. And please do not repeat the sample mean there. We have to have it in unique. So we have the next one as 129. And the next one is 129.75. And next one is we have 130.5. Now, in getting the probability, you are just simply counting how many are with the sample mean equal to 127.5 on your previous table. So we count. This is 1. This is 2. So that means there are 127.5 in there. So that's 2 out of 5 combinations. So we have 5 combinations there. So 2 out of 5, this is equal to 0.5. Next, we have 129 counting. There is only 1. So this is now 1 out of 5 or 1 over 5. That is equal to 0.2. Next one, we have 129.75. That is only 1. So we have again 1 out of 5 or this is equal to 0.2. And lastly, we have 130.5. This is again 1 over 5 which is equal to 0.2. Now, you can check whether you are in the right track or you have the correct probability distribution or sampling distribution here, because if you try to check or add your probability in there, it must be equal to 1. If you remember, under discrete probability distribution, your probability must be equal to 1 and all probabilities must be within the range of 0 to 1, so that you can have that one as the discrete probability distribution. Now, this is similar to your sampling distribution. You must check whether you've got those properties wherein the probabilities there are within 1 and 0 or 0 and 1. And of course, you've got there the sum of your probability must be equal to 1. So checking up, you've got there 0.4 plus zero point 0.2, that's 0.6, and 0.2, that is 0.8, adding 0.2 again, that is equal to 1. So we are on the right track. So we are now ready for constructing or drawing our histogram in here, in which this will help us in analyzing our data later, or this will be easier spotting on what will be our distribution would look like. So drawing the histogram, this is really, really easy. You've got there to list all the sample mean on your horizontal axis. So this is now sample mean. Sorry, on the ink. Let me change that one. Okay, we have the sample mean with your symbol as this one. And again, we have our 127.5 as our sample mean. Then we have 129, and then we have 129.75. And then we have 130.5 as the last one. So we have two probabilities presented in there. We have 0.2 and 0.4. So again, we can draw anywhere here. We can have 0.2 here, and we can have our 0.4 here. So drawing our first probability is 0.4. So that would simply mean that this will be your graph. So that is for the 127.5 as the sample mean. It has a probability equal to 0.4. Next up, we have our 129, and that is with a probability equal to 0.2. And it also follows for the rest of the sample mean. It has a probability which is equal to 0.2. So if you try to look at that one, we don't have an equal distribution of your probability in there with respect to your middle as 129. If you try to recall, we've got the population mean a while ago as 129. And if you try to look at that one, more likely 129 is found in the middle. So again, your statistic, which are the sample mean, may not have equal value of your population mean. So try to take note on that one. So that is how we are going to construct our probability distribution, sampling distribution there. I always make a mistake on the last part. Sorry on that one. Okay, again, so this is how you construct your sampling distribution. So I hope you learned something from me. I'll see you on my next video for another discussion. So don't forget to like, share, and subscribe to my channel, and click on the notification bell so that you will be updated on my latest video.